Hi, this is Gary with more math help. The difference between statistical significance and practical significance is very central and basic to an understanding of statistics. This little video will help you understand that difference. Suppose I've invented a weather machine. I ride into town and I turn it on the first day of June. Then on June 30th, I turn it off and count how many days it rained during the month. In a typical June in this town, it rains 10 days, but this June it has rained 11 days, so I proudly proclaim that I have controlled the weather with my machine. You might not be convinced, because you probably realize that 11 days of rain is not really unusual if 10 days is the ordinary amount. Maybe half the time a month of June would rain during 11 days. Similarly, a month of June might rain in only 9 days. Either way, 10 would still seem normal. Every month of June is a little different from every other month of June, and statistics will help us study the variation between the different Junes. So, statistical significance occurs when the result of an experiment gives us unexpected results. Raining for 11 days isn't really unexpected, because once in a while, 11 days of rain would happen, even without the influence of my supposed weather machine. All of us are surprised by different things, so we'll need to introduce a little math just to standardize all of our experiences. Let's suppose that our threshold for thinking something is unexpected is if it happens only once in every 20 experiments. Once out of 20, in more mathematical terms, is 5%. This is a very common value to use in statistics, and unless we have a special reason for a different threshold, we will always use 5% as our threshold to determine if an outcome is unexpected. Any outcome that occurs less often than 5% of the time we consider to have statistical significance. Practical significance occurs when we would benefit by repeating the action of some experiment. This is very different from statistical significance. Notice that statistical significance is entirely mathematical, but practical significance will always depend on the situation. For example, suppose that I have a new medicine to treat the common cold. After extensive research in the laboratory, we know that my new medicine reduces the time that people suffer a cold. How would we know this? Because we would have calculated the probability of the results we see and found that they are below our surprise threshold of 5%. And just so you know, we will spend a lot of time in this class learning how to calculate probabilities like this one. So, the medicine is proven to work. It has statistical significance because our surprise threshold of 5% was beat. But what if this reduction in symptoms is only 2 hours? In other words, the person who catches a cold might ordinarily cough and sneeze for 5 days. But if they take my medicine, they'll suffer for only 4 days and 22 hours. What would you think of this medicine? You would probably think that it wasn't worth it because of the cost of the pills and the possible side effects for just 2 hours of benefit. In this example, statistical significance is there. We know that the medicine works, but there is little practical significance. No one is going to drive to the drugstore late at night to pick up a medicine that has such a small influence on the course of the illness. With that understanding, let's look at this exercise. They want us to determine whether some results have statistical significance or practical significance or neither or both. Let's read what it says. In a study of a gender selection method used to increase the likelihood of a baby being born a girl, 1,982 users of the method gave birth to 974 boys and 1,008 girls. Let's pause there and notice that this method seems to work. At least in this one study, we did get more girls than boys. We need to ask ourselves whether 1,008 is an unusual number of girls. That is a number of girls this high really unexpected? There were a total of 1,982 babies born, and we should expect half of them to be boys and half of them to be girls. In other words, we should see exactly half of 1,982, that is, 991 of each gender. But suppose we were off by 1. If we had only 990 boys and 992 girls, would we be surprised? Suppose we were off by 2. If we had 989 boys and 993 girls, would we be surprised then? I don't think we would, because there's always a little variation in things like this. But what happens if we're off by as much as we are in this problem, with 974 boys and 1,008 girls? Well, some calculations occur. You'll learn how to do these later, and here are the results in the next sentence of the exercise. It says, there is about a 23% chance of getting that many girls if the method had no effect. In other words, if we repeated this experiment a large number of times, each time with 1,982 couples, then about 23% of the time, just by chance, we would get this many girls, even without any special intervention. This happens because there is an ordinary, regular, typical variation in the number of boys and number of girls born to couples. Do we consider something that occurs 23% of the time to be unusual? No, 23% is a pretty big number. It's way more than our surprise threshold of 5%. This lets us answer the first part of the exercise. It says, because there is a 23% chance of getting that many girls by chance, the method does not have statistical significance. We make this choice purely mathematically, simply because 23% is bigger than 5%. Suppose, though, that you were some parents who had had several sons, but still yearned for a daughter. Even if you were convinced that this method of having a girl baby really works, would you bother with it? Let's use our calculator to find out just how effective this method is. We've already added 974 boys and 1,008 girls to get a total number of births of 1,982. So now we can divide the number of girls, 1,008, by that total, 1,982, to see that about 51% of the births were little girls. These results aren't very impressive. If you were that family wanting to add a girl to your children, would you bother with this method? I don't think so. Not many couples would likely use a procedure that raises the likelihood of a girl from the approximately 50% rate expected by chance to the 51% produced by this method. So this method does not have practical significance. You'll notice here that I have followed these blue instructions and rounded the percentage to 51. Let's check our answer. And it looks as though we are on track with this exercise. If you want a quick summary of the difference between statistical significance and practical significance, you can think of it in this way. Statistical significance is when you say, huh, that's surprising. And practical significance is when you say, wow, I'm going to try that. Thanks for watching.